Hello everyone, welcome to the learning platform escholar.in. So today we are going to deal with the paper Mechanics and General Properties of Matter. So we will be looking into a very important topic in this paper, which is velocity and acceleration in different coordinate system. So every one of us know what is velocity. So velocity is nothing but rate of change of displacement. Velocity is nothing but rate of change of displacement. So displacement will give us the position, right? Rate of change of displacement. And the next is acceleration. So what is acceleration? So acceleration is nothing but same, the rate of change of velocity. Acceleration is rate of change of velocity. So next what we have to look at is coordinate system. So why do we need a coordinate system? So we need a coordinate system for the very easy analysis of a motion of a body. So we need a coordinate system for an easy analysis of the motion of a body. So in general, coordinate system, we can classify it into two types. So the first would be two-dimensional coordinate system. So in two dimension, we will be having two types. So the one is Cartesian system. So the one is Cartesian system and the other is plane polar. And the other is plane polar. Right? Plane polar. And one more is three-dimensional. So in three-dimension, we have three types. So the first one is the same Cartesian. And the next is spherical coordinates. Spherical. And the last one is cylindrical. Cylindrical. Right? So we'll be looking into detail of each coordinate system. So right now in this class, we will be looking into the Cartesian system and plane polar. That is the 2D coordinate system. How we are going to write the velocity and acceleration in the respective coordinate system. So let's get into the first, which is two-dimensional Cartesian system. So two-dimension Cartesian. So let me take two orthogonal axes, x and y. So this will be my x-axis and this will be my y-axis. They are two orthogonal axes. So let me mark a particle which is located at the point P. So now to write the position of this particle. So this would be our position vector r vector. So this distance it would be y and this distance it would be x. Right? So the position of the particle will be given by the position vector. So we have to write the position vector over here. So r vector is given as xi cap plus yj cap. Okay. So this is I cap. So position vector is given by xi cap plus yj cap. So here I cap and j cap are unit vectors. So I cap is the unit vector which is increasing in the x direction and j cap is the unit vector which is increasing in the y direction. So let us write our velocity and acceleration terms for a 2D Cartesian system. So we know that velocity is nothing but rate of change of displacement. So it is dr vector by dt. So this can be written as d by dt of xi cap. So our r vector is xi cap plus yj cap. So I have to differentiate it. So this would be x dot I cap plus y dot j cap. So what does x dot represent over here is, it is nothing but dx by dt can be written as x dot. So this will be our velocity term in a 2D Cartesian system. Right? And the next one is acceleration. So acceleration is nothing but rate of change of velocity. So it is dv vector by dt. So it can be written as d by dt of x dot I cap plus y dot j cap. So our acceleration will be equal to x double dot I cap plus y double dot j cap, right? So here x double dot represents d square x plus, sorry, d square x by dt square. So this x double dot is nothing but d square x by dt square. And our acceleration in the 2D system is given by x double dot I cap plus y double dot j cap, right? So these are the velocity and acceleration terms in respect to 2D Cartesian system. So since we saw about the 2D Cartesian system, I want to make sure over here itself regarding the 3D Cartesian system because it will be easy for you guys. So let us look into the 3D Cartesian system. So it's a 3-dimensional Cartesian system. So let me take 3 orthogonal axes. So this will be my x-axis and this is my y-axis and this is my z-axis and let this be origin. So I am having a particle P over here. So the axis would be x, y, z. So over here my position vector. So position vector is, this is a position vector r vector. So position vector is given by x I cap plus y j cap plus z k cap. So I vector, j vector, sorry, I cap, j cap and k cap are unit vectors. So let us first write the term for velocity. So velocity, so v vector is given by dr vector by dt. So it's the same as how we did before. So our velocity will be x dot I cap plus y dot j cap plus z dot k cap, right? And next let us write the respective term for acceleration. So for acceleration, it would be dv vector by dt. So this would be x double dot I cap plus y double dot j cap plus z double dot k cap. So it's similar just as how we did for 2D Cartesian system. So this is the term which is corresponding for the acceleration. So here I have a small tip note which you people have to remember. So it's a note. So what is the note is, since and one more thing, so this x double dot, this would correspond to ax, that is the acceleration in the x direction. So x dot can be written as x double dot I cap. So I can write my acceleration term as a vector is equal to ax I cap plus ay j cap plus az k cap. Az k cap. Hope so it's fine for you guys. So this is the acceleration term. So what is the note I have to give over here is, since we know ax, that is acceleration in the x direction, can be written as dvx by dt. So if your velocity is a constant, then your acceleration will be equal to 0. So then your acceleration will be equal to 0 because differentiation of a constant is 0. So if your velocity is a constant, then your acceleration in the respective direction would be 0. So this note is valid only in Cartesian coordinate system. So this is valid only in Cartesian coordinate system. So it is not valid in other coordinates like polar, spherical, cylindrical. It's valid only in Cartesian coordinate systems. Right? Hope you got regarding 2D Cartesian system and 3D Cartesian system. So now let us move into the next coordinate system, which is plane polar coordinate system. So next we are going to look into plane polar coordinate system. So plane polar. So plane polar, where do we use this plane polar is over a 2D surface, or else if the motion is a 2D motion. If the motion is a 2D motion, right? So here let us take two orthogonal axes x and y. So I am having a particle P. So the line joining P and the origin. So this is called as a radial direction. So this will be a radial direction. So and there is an angle which is making at an angle theta, which is in the anti-clockwise direction, not in clockwise direction. It is in anti-clockwise direction, and this is r cap. So the coordinates which we use in plane polar is, so the coordinates which we use in our plane polar is r and theta, and the unit vector are r cap and theta cap, right? So if the position of the particle, suppose if the position of the particle is changing, then your angle would also be changing, right? So in this case, your r cap and theta cap are variable vectors. They are not independent. They are variable vectors. R cap and theta cap are variable vectors. They do not depend, they depend upon the position of the particle. Whereas in your Cartesian system, they are independent vectors. But over here, they are variable vectors, right? So let us see how the acceleration and velocity terms in plane polar coordinates are going to come. So let me take two axes, x and y. So let me have a particle P over here. So my radial line, that is the radial direction, would be this way. So this is r cap and my theta cap would be perpendicular to this, right? So this would be my theta cap. So my unit vectors, that is I cap and j cap. I cap and j cap. So the angle over here, this would be theta, and this angle it would be 90 minus theta, because the angle formed over here it is 90 degree, and this angle would also be theta, right? Since, okay, I have not marked this angle, so this is the reason why we are having over theta over here. So let us first write our r cap and theta cap. So what would be my r cap? So r cap is nothing but cos theta I cap plus sin theta j cap. So this we have written by the resolution of vectors. And the next is theta cap. So theta cap is given by minus sin theta I cap plus cos theta j cap, right? So we have got our theta cap and r cap terms respectively. So first let us find the velocity. So concentrate and listen to the video because it's very important for your problems. So velocity is nothing but dr vector by dt. So I can write my r vector as r into r cap. Okay. So let me replace it over here. So my velocity will be d into r cap by dt, right? So r cap is a variable, but it is not a constant. Remember guys, r cap is a variable. Over here it is not a constant. So let me split it and write the differentiation by chain rule. So first it is r dr cap by dt plus r cap into dr by dt. Okay. So let us do first the differentiation separately. So what it is dr cap by dt. So we know what is our r cap. So before that, let me split these also. So I'm multiplying and dividing it by d theta. So it is d r cap by d theta into d theta by dt. So now I can write this as theta dot. So d theta by dt is theta dot. So theta dot into d r cap by dt. Right? So this would be theta dot into d by dt of, what is my r cap? It is cos theta I cap plus sin theta j cap. So I have to differentiate these terms. I'm sorry, over here it is not dt, it is d theta. We have to differentiate with respect to theta, not dt, it is d theta. So let me write it. So theta dot, differentiation of cos theta, it would be minus sin theta I cap. So minus sin theta I cap plus cos theta j cap. Right? So if you look into this term carefully, this is nothing but our theta cap. So I can write this as theta dot into theta cap. Okay? So I'll do the next slide. So our v vector will be equal to r dot r cap plus r theta dot into theta cap. Right? So now we have find our term with respect to r component. Now let us try it for theta cap. So let us calculate for d theta by dt. So theta cap by dt. d theta cap by dt. So by applying chain rule, we write as d cap by dt into d theta by dt. So I can write this as d theta by into d theta cap by d theta. So we know theta cap into d by dt of, what is our theta cap? Our theta cap is sin theta I cap. It's minus sin theta I cap plus cos theta j cap. Right? So now on differentiating this, we would get minus cos theta I cap minus cos theta I cap. Again, differentiation of cos theta would be minus sin theta j cap. So let me take the minus sign common out. So this would be theta dot into, minus I am taking in common. So this would become cos theta I cap plus sin theta j cap. Right? So if you look into this, this is our r cap. So d theta cap by dt will be minus r cap into theta dot. Right? So now let us look into the velocity term again. So our velocity is nothing but r theta dot theta cap plus r dot r cap. So we will say this as the transverse component of velocity, that is with respect to theta cap. So we will say this as transverse component of velocity. So this is very important for your problem. So this is nothing but the transverse component of velocity. So we can say this as the transverse velocity term. And this term r dot into r cap. So this can be said as the radial component of velocity. So this is nothing but the radial velocity. This is the radial component of velocity. Right? So this is very important for your problems. Please do remember it. So let me write my velocity as v vector is equal to vr r cap plus v theta theta cap. So where VR is nothing but r dot and v theta is nothing but r theta dot, right? So these are the important results which you have to remember for your problems. So practice it for 2 to 3 times, you will get a touch with it. So now let us move with the acceleration term. So we will write our acceleration as dv vector by dt. So acceleration is nothing but rate of change of velocity. So just 2 minutes back we found what is the velocity. So velocity is nothing but r dot into r cap plus r theta dot into theta cap. So let me differentiate this. So it will be d by dt of r dot r cap plus r theta dot theta cap. So we have to write it separately, each and everything. So it is r dot into dr cap by dt plus r cap into dr dot by dt plus, so let me write for each term separately. So this will be theta dot theta cap into dr by dt plus r theta cap into d theta dot by dt, and last we will have r theta dot into d theta cap by dt, right? So we have to do one by one. So we know that dr cap by dt, which we did last. So dr cap by dt is nothing but theta dot theta cap, right? Similarly, we know what is d theta cap by dt. D theta cap by dt is nothing but minus r cap into theta dot, right? So let me substitute all these in the equation. So this will be r dot theta cap plus r cap into dr dot by dt would be r double dot, right? So double time. So r double dot plus theta cap, and dr by dt I can write it as r dot plus r theta cap, d theta dot by dt is nothing but theta double dot plus r theta dot. So d theta cap by dt is minus r cap theta dot. So let me write the terms once again so that we will get. So let me write the terms once again so it will be easy for us to split and write them. So acceleration, what we got from our previous step is r double dot r cap plus r dot theta cap plus r dot theta cap plus r theta double dot theta cap plus r dot into minus r cap theta dot, right? Theta cap. So let me add these terms. So we will get as r double dot r cap plus 2r dot theta cap plus r theta double dot theta cap minus r theta dot square into r cap. So let me split the r cap and theta terms. So these two will be together and these two will be together. So it will be r double dot minus r theta dot square into r cap plus 2 r dot theta dot plus r dot theta double dot into theta cap, right? So this term will be my AR. So AR is nothing but the radial acceleration. AR is nothing but the radial acceleration. So this is the term which is corresponding for radial acceleration. How we saw transverse velocity, radial velocity. It's the same like that. So it's radial acceleration and this term will be the transverse acceleration. This term, this is nothing but AV, which is the transverse acceleration. So this is the transverse acceleration, right? So here also I have a small note for you guys. So if your radial acceleration is 0, then your radial velocity may not be a constant. Your radial velocity need not to be a, sorry, may not be a constant. May not be a constant. So remember the radial velocity and transverse velocity. Similarly, radial acceleration and transverse acceleration. So that's it for today's class. So we have seen 2D Cartesian system, velocity and acceleration terms, and 3D Cartesian system, velocity acceleration terms, and for plane polar coordinate system. So revise these terms. So in my next class, I will be saying about how the velocity and acceleration terms will be in spherical and cylindrical coordinate system with few problems for your practice. So students, keep practicing. Thank you everyone. Bye bye.